Okay, I hope I'm recording. In this video, I'm going to address this painful and horrible issue of discounting in the discounted cash flow model with half year or full year. It's an easy place to get very confused. Now, there's music in the background. I refuse to go to Starbucks coffee. Sorry about that. And so I'm at some other place with the radio going. Here's what this exercise is going to demonstrate. We're going to show you, maybe most importantly, the importance of a proof. How you can prove different things, so you don't have to get into these incessant and horrible arguments about which way is right. Everybody has their own little opinions, and nobody believes everybody else. And frankly, I was wrong about this one until I made a proof. So we're going to assume a transaction occurs sometime in the future. We're going to put alternative terminal value dates in here. We're going to put in a weighted average cost of capital. This is an extremely high WACC, obviously, a terminal growth rate. We're going to put some starting cash flows and a different growth rate over the explicit period. And then we're going to make a valuation year that's not the transaction year. So we'll pull it ahead of time. And then, oh God, I've got a... Here, let me just... Sorry about the radio, but I just wanted to get this done. Okay, I'm also going to put in a factor. Now, if you put 0 here, that's going to assume an end of the year. 0.5 is going to be middle of the year, and 1 is going to be a full year. 0.5 is generally the assumption you should make for an annual model, because I don't know, maybe some companies get all of their money on the very last single day of the year, but I would think that's fairly rare. So 0.5 assumes essentially you get it in the middle of the year, which is something like, not quite, but something like, assuming the cash flows occur on a continual basis over the year. If you have a really high rate of growth, you may get some and a high cost of capital. What would happen? Wouldn't you get a little more revenues at the end of the year? So there's, I guess, a little bit of a optimism thing here. Now, what I've done is put different switches in here and made a valuation of the cash flows using a discount rate, and I'm going to put periodic discounting that adjusts for these things. And then we do a terminal value calculation and work through some of these. Now, the key behind this whole thing is how can we prove which method is correct? And to prove which method is correct, why don't we make a 300-year model? Now, I think, would you mind, I'm going to set up this model. I'm going to make our normal coloring macro. I hope oh, great. Oh, crap. Oh, great. I have some other things open. Screw this. Shift Control C. Okay, I already have a macro there that does that. And so those are our inputs. And why don't I make a little thing that shows our shows our equations. And this is this function to show the formula. was a little quiet there, just putting that in. Now, what we can do, then I'm just going to show all these formulas. Show formula, I hope. Hope I did it right. Okay. So we'll make a little column here. So if you would later want to see what's in each of the formulas, you can do this. Now, oops, shoot. See, I'm saying shoot instead of shit, because I'm being very proper here. Great. What did I do? Crap. Crap. See, crap. That's more polite. What's the growth rate? Oh, screw this. Let's forget about the formulas. Okay. I'm going to delete this column. Okay. Maybe I'll put some comments in here. And great. What did I do now? Oh, no. Okay. Let's see how many times I can undo. Okay. Enough of that. And I'm not starting over. I should kind of start over, but I'm not. Let's just hide this. Cell. Okay. Now I think I'm going to try something a little new this time. Now, what this the whole point of this exercise. Why don't I make a little comment? The whole point of this exercise is that it demonstrates that you should discount the terminal value at the 1/2 with the 1/2 year assumption and compute the terminal value using the normal formula TV equals CF times 1 plus G. No need to make any sort of adjustment to the growth rate divided by the WACC minus the growth rate. Okay? No special adjustment necessary. That's the point of this exercise. Now, to get there is a little bit of pain. So I'm going to call this our completed exercise. And let's make a blank exercise. So let's copy this to here, and this time, suppose I'll leave that open. No, I won't. I'm going to delete that cell. We're going to delete this whole thing, and now this is going to be fairly boring. That long-term thing proves that here, it proves that we get the same answer when we do a long-term or not. Here comes some advertisements on the radio, of course. I wonder why. So here is our let's start with just the inputs. How's that? Okay, and I'm going to call this exercise blank. Okay, and now I'm just going to work through this exercise with you. I think some of the techniques here are certainly worthwhile. Okay, so I'm going to copy this just because you might want to work through the whole blank exercise. I'm going to copy that over to here. All right, let's start with. Actually, let's start even here. Okay. I wonder if I should have done it. Okay. So the very first thing to do is compute the terminal U. And if the transaction occurred in 2016, we add the explicit period, and then we better subtract 1. Okay, so if you can count this on your fingers, that's what I have to do, but I'm sure you're much smarter than me, so you don't have to do that. 2016, 17, 18, 19, 20, 21. The end of that 2021 is when we'd finish this. Now, you know, why don't I do this? I think for this exercise, it'll help if we put our titles in. I hope you don't get angry with that. You know, some of these exercises, it might be better if you if you even start without the titles. So the first thing to do, if you're working with dates, I think this is so important, is to compute a series of switches. The first switch, we're just going to take this top switch and see if it's, oh, I didn't tell you this, but we're going to make a valuation year. Okay, this valuation year, this is the year to bring back the NPV. Now, I suppose we could put a valuation date. Now, the main reason to use this is to demonstrate the XNPV formula as a proof. Okay, you can get confused with this XNPV and this factor. This is if it's the end of the year, then we put then we enter 0. If it's the middle of the year, then we put 0.5. If end of year, then put 1. All right. Let me put a capital if there. Okay. So that's what that factor means. Now the valuation switch. This is simply, we take this year and we just put an equal sign to the valuation year. Some people might want a range name here. Now let me see how this works. We went all the way out to the year 2312. We went out 300 years. I did that with the shift control right arrow, shift alternate right arrow. Okay, now we have, hopefully we have one true here, you know. And the other thing, I think it's going to be a good idea whenever you have these switches, it's a nice idea to record a little macro. Whoops. Here, and let's call this true switch, because I think we should color this. Now, hopefully there's not one already there. Oh, great. Crap. Okay, I'll just use the one I have open. That's, oh no, Shift Control T. And this is embarrassing. Okay, I'm going to make it Shift Control G for some stupid reason, because it shows you that you should close your workbooks and show what macros you have. And this is embarrassing, but I'm not going to stop this one because I hate this thing. Okay, there we have it. So I forgot what I call it, some kind of macro. Now I'm just in one single cell going to go to Home, conditional format, highlight the cell rules, text that contains. Now if this is French, it would be V for vrai, so this macro wouldn't even combine it. And what did I just do? I guess let's shift control right, arrow shift controls G. There, we just showed what's true. Now, the next one's more important. For the explicit period, that goes from 2016 to 2021. This one's this is the year cash flows begin. That's all that is. So we want to go from 2016 to 2021. So let's put an AND function and always begin with the year. That took me so long to realize, and it's so obvious with hindsight. And then we said that has to be greater than or equal to, greater than or equal to the transaction year, and this year has to be less than or equal to the terminal year. You can talk to yourself, maybe that's good. Then we can press Shift Control G. Sorry, maybe I'm going to stop with these horrible shortcut key macros. They're so easy to make. You see that maybe there's some method by which this would overwrite. Please send me an email if you know that. Now let's just make another switch and just say that this year now equals the terminal year. The reason this switch will be so important, Shift Control G, is because that switch is that's the only period in which we get the cash flows. Now the discounting switch, let's put just a switch that says we just have to take this year, and when this is greater than or equal to the valuation period, because we want to bring all of these cash flows back to that period. Okay? And finally, it'll be helpful, you'll see, for the long-term proof to just have something that switches off the cash flows before the transaction period. Okay, so the pre-transaction period is this year is less than this transaction date. Okay. Shift Control G. All right. That's helpful, I think. I hope you will see that this investment really works out. Now, well, I'm gonna leave the X NPVs and the dates out just for a few minutes here. Oh, we're already at 18 minutes. If you've watched this, you've already wasted 18 minutes of your life on this. Our free cash flow, what we want to do is take our 100 of starting cash flow. So our cash flow, and this begins in the transaction period. This grows by explicit growth rate over transaction period, and it grows by the terminal growth rate after the transaction period. Okay. All right, and then so let's compute our free cash flow, and then we'll just kind of verify that growth rate. You know what I'm going to do? I'm going to do it a little bit differently in this one. So what we want to do, I think we need an if statement. If it's the did we put a transaction date? If it's the, excuse me for this. So if it's the why don't we use the I think I'm gonna enter a new variable for the date so we can get beginning. This one equals the okay. Just because here's why we need that. If it's the transaction date, then we're just going to say we've got 100 of cash flows for that year. Now that doesn't deal with this issue of the growth rate during the year. And otherwise, we take the prior year, that's why I was getting those problems, times 1 plus the growth rate. Now, why don't I make a, before I do this, that's okay. You can see, let's put another switch for post terminal period. Okay, let's just say this one has to be greater than the terminal value. Okay, I hope you're not getting irritated with me. You'll see. Now, why don't we, I'm going to move the growth rate up to here. I think this will save us some time in the long run. So for the growth rate, we could just take this switch. We could take the explicit growth rate and multiply that by the explicit period switch plus the post terminal period times the terminal growth rate switch. This is going to be important for our proof. Okay, so our free cash flow, if we take a free cash flow over the entire period, our free cash flow is just the I think, why don't we put a growth rate index here? Okay, let's start with 1, and let's say it's this one times 1 plus the okay. And I wonder if I should do this differently. The cash flow, if we really suppose we could do a growth rate index. This is end of the year. Now, what we could do is make a growth rate index periodic, because we could say, okay, let's take, what should we do? If it's the middle of the year, we would take this growth rate multiplied by, why don't we do it like this? This is the growth rate index end of the year. Whoops. Oh, come on. What happened here? Okay. And then we got growth rate index beginning of the year. I'm making a little different example now. Okay. And that would say, okay, let's multiply this times 1 plus, and not this growth rate, but the prior growth rate. Alright, so what we have is, in the first year we're actually just growing our cash flows by half the year. Okay, and let's just put the average of this and this. So let's just talk through this. If we have 100 of cash flow and that is growing on an annual basis by 10%, some of that growth occurs in the for January 1st, you'd have the end of the year, you'd grow the whole cash flow. But if we're starting with the 100, if you had a December cash flow, there's no growth if the base value, if somehow the base value is 100, if you have selling some units and so forth. So why don't we use this middle year cash flow, and then now we can compute our, why don't we put our free cash flow over here, and so our free cash flow is just this one multiplied by the middle year growth index multiplied by the where's the switch? What switch should we use? I didn't have one. We need well, let's put a cash flow switch. I'm going crazy with these switches. If I put equal, whenever this post-terminal period doesn't equal the explicit period switch, then that's the entire lifetime of the switch. So let's take this one and multiply it by the cash flow switch. Oops, yeah, exactly that. I did it right. Okay, and then also let's multiply it by the growth rate index. That kind of was a long time to get that. Now, if we we want to start the valuation, and this is, I hope you'll see a little bit why these switches might occur. Let's start this valuation in the discounting switch. So we want to start the valuation in 2014. Okay, so this one, if we just add the true, this one plus the discounting switch, then we're able to do that. Now, here's the problem. If we want to discount this, if this cash flow occurs here in the middle of the year, discounting it to the 3 years would, when we bring it back to 1, this discounting would be assuming these cash flows occur at the end of the year and bring it back to the beginning of 2014. So what I would do is put a periodic discount factor, 1 divided by, now if you have a changing discount rate, this all has to be a little bit of a difference. I'm going to leave this for now. We'll take this one and raise this to the power of 1 minus this periodic factor. Okay, that's our discount factor. 1 minus raised to the, excuse me, the period. That's why we put this here. Okay, now if I want to get the value of these cash flows, I just multiply all of these values to here. It brings it back to exactly this place, brings it back using a half-year convention. So our value of our cash flows is the sum product of all of the discount factors multiplied by, I use the multiplication here, multiplied by all of the cash flows. Okay, now to demonstrate that this gives you the right answer, let's do the same sort of exercise with the XNPV. Now, let's just first define the beginning of the period. So on these lines I'm going to put the dates. So if I just take equal date and just put comma 1, comma 1, we get and let's put shift control 3 to get a regular format. So that gives us the date. Now, I'm going to we want to bring it back to 2014 up here. So if we want to bring it back to there, here's what we can do. We can put, if it's the pre-transaction period here, then see, there was a reason for putting that switch. Then we'll just lock in this date. Otherwise, we'll make it the average of this date and that date. So what will that will put it in the middle of the year. Let's see, Shift Control 3 to get a date. So this just held it at 2014, and then in this year of 2016, which is our first year, we get it in the middle of the year. If we want to do something at the end of the year, we'll do the same thing. If it's the pre-transaction period, then let's just use the same thing we used before. Otherwise, let's use EO month of the beginning of the period, and I think we have to press 11. The only reason I know that is because I made an error. So what that does is say, okay, let's put the cash flows exactly at the end of 2016. So now if we made our explicit cash flows with the middle of the year period, we put XNPV, shade the cash flows. That's the thing that took us so long to do. And then after you do that, shade the middle of the year date. And of course, I put a I'm not going to answer that phone. It's just my friend who bothers me all the time anyway. Let me put the WACC in here first, the annual WACC. Let's put the free cash flows in first, and then after we put the free cash flows, we said we were going to put the middle of the year date. And this gives us a number that's close. The reason it's not exactly that is, a couple of things. We put July 2nd. I think July 2nd is okay. And the other thing is the XNPV assumes 365 days and doesn't incorporate the leap year. Now, if we did the same thing and used, instead of the end of the year, the beginning of the year, we'd first put the WACC in, and then we put the cash flows in as usual, and then after you put the cash flows in, put the cash realization date. So what happened is it made a pretty big difference. Now the reason it made a big difference is I used the pretty high discount rate. In fact, it gave us an extra 7% value. Now the confusing part is, what should we do for the terminal value? When we sell this company, here's the thing to understand. When we sell this company, where is our terminal period? This is what confused me, and I'm going to do it two ways and show you the why you don't have to do all of this business. But here is the problem. You want to, when you sell the company, you're going to earn this 169 over the course of the year. You've got that. Some of this is January 1st, some December 31st. Now when you sell the company here in the terminal value, you're going to sell it right in December at the end of the year. So the discount factor for the terminal value, unlike the other one, is 1 divided by 1 plus the WACC, of course. But this time we're going to raise this to the power of simply the period of the valuation. We don't subtract anything. I'll put 0 always. Okay, so that gives us an end of discount year. Now if we do the normal discount terminal value calculation, here's what we do. We take this one, multiply this by 1 plus the terminal growth rate, and then we once we multiply that by the terminal growth rate, let's divide that by the WACC minus the terminal growth rate, and finally let's multiply that by the explicit terminal switch. So that's our, I hope, if you, in case you haven't seen some of the other stuff I do, this just makes the terminal value a completely flexible kind of calculation. Now, if you, what we can show, and I'll show, is if you if we would move this around, if we would move the terminal value around, let me just make this calculation. 1 plus the whack raised to the 0.5. If we put 1 in here, it just gives us the whack itself. Maybe I'll put an extra decimal or two here. If we put 0.5, this is how much extra value you get by selling something early. So here's the problem. We're going to show you that the problem here is when we applied this whack, oh no, another advertisement. When we adjust the terminal value 1 plus g divided by whack minus g, now if they get it in the middle of the year, we can't use that same formula, and what we should do is take that formula and multiply it by this factor. Okay, so we push the value up a little. Now, when we do this, we get the value of the terminal. So this is some product, and we take the all this cash flow, and then we multiply that by the discount factor. Okay, so that gives us our terminal value, and then we take this one and add the what do we want to add here? Our explicit cash flow. Okay, that's our total value. All right. Now, if we did the same thing, here's the trick. We didn't have to do all this crap. We could have used this one and used this terminal value and get the same thing. So this is the big lesson. This is the whole reason. Whoops. I'm getting so excited. If we would have just taken the non-adjusted terminal value and multiplied that one by the periodic discount factor. Oh, great. I thought we would have got the same thing. This one should have been the adjusted factor. Okay, we would have got exactly the same thing. Now, to prove all of this, let's make a long-term proof. Let's go up to the post cash flow. Well, let's use this cash flow switch. So this is going to be a long-term analysis. Okay, and we're going to, we don't need these anymore. And in fact, that's what we did. We don't need this anymore. So we actually have this total cash flow over the entire period. I think we got this cash flow, and we just did that over the whole entire period. Now our discount factor, if somebody was valuing this whole cash flow over the entire period, our discount factor would be, all the cash flows occur in the middle of the year. So we use this periodic discount factor. And now our theoretical value is the sum product of all of these times all of these. Oh crap. It's supposed to be exactly the same. I made a mistake up here. I don't know why I did this, because we should have only taken these cash flows over the explicit period, of course. And we should have made some sort of adjustment in here. I'm going to move this down to the bottom and call this XNPV proof. Okay. So now when we total enterprise value, and why am I getting a little bit of a difference in value? I'm sure this is a